Hello everyone, I'm gonna solve a problem about oscillation. This is a problem from the mastering physics of my class, and here's the problem. So I'm gonna highlight some of the keyword in this problem. It is said that Galileo discovered a basic principle of the pendulum, that the period is independent of the amplitude. By using his pulse to time the period of swinging lamps in the cathedral as they swayed in the breeze, suppose that one oscillation of a swinging lamp takes 6.2 seconds. And we're gonna solve for these two questions. First is, how long is the lamp chain? Which is, we need to find the length of the lamp chain, and what is the maximum speed, and does the lamp have, if its maximum angle from vertical is 3 degrees. Okay, let's begin drawing some picture. So the lamp gonna swing here to here, and then it's going back, then it's finished one oscillation, and one oscillation takes 6.2 seconds, which means our period is 6.2. And we have the equation of the period as t equal to pi square root of the length over gravity. And from here we know the length is gravity t square over 4 pi square. And we already know Earth gravity is 9.8 times the period is 6.2 square over 4 pi square. And we do some calculation. The answer will be 9.5 meter. Okay, so we finished this part. So let's see if this number makes sense. So we know 2 times pi has to be 6 something, because pi is equal 3.14. So it has to be like around 6.28. And as we have our periods is 6.2, so this part right here, square root length over gravity, has to be around like 1 and 1, so it could be this is square root of the length over 9.8, so our length has to be around like 9.0 to 9.8, and we got this answer is 9.5 is in between 9.0 and 9.8. So this answer makes sense to me. Okay, next we're gonna move on to the part B. Part B, for this, we need to draw another picture. So we know the maximum angle is theta equal 3 degrees. So for this problem, to find the, we need to find the maximum speed, Vmax. So I would know when it's swinging, the maximum has to be right here at the bottom, like right in between right here. It cannot be here or here. It has to be here. And so for this problem, I'm gonna use potential energy to solve this. So I'm gonna compare I'm gonna compare. This is our initial position of the lamp, and it's moving right here. So we got the 1/2 mv initial. I'm gonna say this is position 1 and position 2. So 1/2 mv1 square plus mgh1 equal 1/2 mv2 square plus mgh2. So we have from here, the h1 is going to be from here to here, and h2 equals 0 over here. So this is h1, and actually to solve h1, we know this part is the length L, and right here is also the length L, and this part also the h, and this triangle is the right triangle. And to find the h1, we just gonna take this part minus the small part right here, and the small part right here actually L times cosine of theta. So we know h1 equal L, the length of the lamp chain, minus this one times cosine of theta equal this one. So cosine theta is 9.5 minus 9.5 cosine 3 degree. And we do some calculation, and we will get 0.013 meter. So continue with this part. So right here we know V at this position equals 0, as is the position is at the maximum angle. So this one is 0. And we know that the position, the height of when the lamp is right here is equals 0. So right here equals 0. So we cross this one and this one out. We got these two. In these two, because we have the same m, the same mass, so we also cross it out. So next we will have gravity h1 equal 1/2 v2 square, which is our V max. So v2 equal to gravity h1 square root, and v2 actually is V max, our V max right here. So it's gonna be 2 times 9.8 times 0.013 square root the whole thing. Then we will have V max equal 0.51 meter per second. Okay, so we got it. And I think this V max is 0.51 makes sense, because the angle is very small, the maximum angle is very small, and the period is 6.2 seconds. So so I think it should not move too fast. It cannot be 1 meter per second. It has to be lower than that. So as This number is right at the range that I imagine. It should be between like more than 0 but less than 1. Okay, thank you for watching.